Good morning, everybody, and welcome back to Nextdoor NetAdmin. Today, I was thinking that I would talk a little bit about overlay networks, which, when you think about it, you might go, I already know about that. It's kind of like a VPN, right? Let's start and think about where each one of these concepts comes into play. Because if you think about it, one of the first steps along this path is the concept of NAT. NAT, how does that come into play here? Well, network address translation, everybody knows what that does pretty much. You have your inside addresses within the network, and then when you go to the external network, to the internet, you take that data and you substitute the from address so that instead of coming from an internal network address, it's now coming from the external network address. And that's how most people think about NAT, is there's the inside source versus the outside source. But NAT can actually be done in many places. Network address translation can also be done on the destination address, so that the inside says, I'm going to send to 192.168 whatever. But when it gets to the router knows, okay, but the external network doesn't understand that address. So I'm going to say, okay, this is now destined to 10.0. whatever, or whatever other type of address is necessary. And it can translate that on the outbound to go to a different destination entirely. So we're still sending the data, but we're substituting one or some of the addresses. And you can do multiple types of network address translation. You might swap out the source and the destination. And then when you get to the other end of that connection, that might also swap out the source and the destination. Again, you might go through multiple layers of NAT. It can all be very confusing, but if you're only doing network address translation, okay, you can do that on a one-to-one basis. Where it gets more complicated is where you do port address translation or NAT overload, or if you also have a firewall in there so that you have to do port forwarding, it just gets messy. But just stick with me for a moment and think about NAT. Broadly described, we have a packet of data, and we're going to change some of the addresses in some way and relabel them before we send it out. Okay. So then you start thinking about, okay, well, what are other ways that we can do this kind of translation? What if we have a packet of data, we have data, and we have the source being some internal sort of network? What if we just kept that the same and sent that through our gateway onto the internet to a remote system where we want it to see that source address directly? You could do that. But could you actually? Let's say that you've got two internal networks. They're both using RFC 1918 internal networks, 192.168. whatever. Let's just go with that. Okay, well, if you send a packet from that source to, what's your destination? Well, your destination has to be the external IP address, doesn't it? Because the rest of the internet doesn't understand RFC 1918. Okay, so you get there, it has to understand where it's going, right? Let's say you have a pool of NAT addresses that it's a one-to-one translation. Okay, you can substitute it again and say that it came from a 192 address and is going to a 192 address. And then you'll have to do the same thing on the way back. It's going to a 192 address, wipe that out. Okay, well, put it on, send it to the external address. Okay, and then on this side, wipe it and send it over into there. That's a lot of hassle. It really doesn't work well. And if your internal nodes actually have the knowledge of what the external addresses are, why wouldn't they just send to those external addresses? It's a lot of complication at the router level, so what we introduced was the concept of encapsulation, where you take your internal packet, you say, okay, you say you are from 192.168.1, and you're headed to 192.168.2. Rather than having to do some sort of funky double address swap on this end and that end, let's just take this packet and wrap it up, and we're going to encapsulate it into a new packet that says, actually, I'm from 172.18, and I'm going to 172.17. Okay, sure. Send that through the internet, and when it gets to the other side, it decapsulates it, takes it out and says, okay, my packet actually says that it's from 192.168.1 headed for 192.168.2. Let's just send that on. Then your endpoints don't need to know anything about the external network that is being traversed. It just knows that it's talking to a station with an address. You don't have to worry about that translation. You don't have to worry about swapping out the source or the destination and swapping it to all that stuff. Just goes away. That can be abstracted. You're just encapsulating a packet as it goes through. Okay. This is a standard VPN. Cool. Standard VPN has single server locations. You connect to a VPN server and you send your data as if you are a local client. Or, alternately, you might have a site-to-site tunnel where you have two servers that are connecting a tunnel between the two of them, and they handle the encapsulation and decapsulation as you go through the network. Strictly speaking, these do not have to be routers or gateways, but it is pretty traditional that they would be, because that's where all the traffic is entering the local network anyway, usually. You can have a specialized VPN appliance if you're looking for something that does high throughput, sure. But most of the time, we're going to co-locate that with the actual router and or gateway in a somewhat heftier system, because it just makes sense that way. All right. But what if we want to do something more complex? What if, in fact, we want to do this same sort of encapsulation of data, but we don't want to have to send it to a server? Or what if we just want to say everything is a server and everything sends VPN traffic to everything else? That's certainly more direct. If you're trying to go, okay, so you go, well, from this client, I have to go to the main site, and then I'll go talk to this client over here. Well, why don't you just go straight there? When you start getting into a full mesh type of point-to-point VPN, what you actually arrive at is something which can be more broadly and more abstractly called an overlay network. And we're working on the same principles. An overlay network says, okay, well, I have a 192.168.2 address over here, but I'm also connected to a network of 10.0.1. So I'm going to send a bunch of traffic along 192.168, but I'm also going to send some traffic through 10.0.1. And when I do that, I have to encapsulate that and send it out through 192, and it'll have to go to another destination. And then when it gets to that destination, it says, okay, this is encapsulated traffic. So when I unencapsulate it or decapsulate it, oh, this is actually 10.0.1 traffic. Oh, so I can process it like this. And it doesn't matter anymore what your underlying transport is. You've fully abstracted this. You don't have to go through a router. You don't have to go through a VPN server somewhere. It's just every device talks to every other device. That's the idea. Okay. Do we have examples of this? Well, yes, obviously we do. There was a product quite some time ago called LogMe and Hamachi. Hamachi was essentially a VPN, and it was called a VPN, but it actually functioned more like an overlay network. It was very big in the gaming community, as I understand it at least, because you would put this on people's PCs, not necessarily to create a VPN for sharing data, although you could, but basically so that you all became one LAN and you could use your LAN functionality for gaming over the internet. So that you could take something that could handle LAN gaming but didn't have internet servers for online matchmaking or anything, and you could just play a basic LAN-based game on your local network. Hamachi actually provided that overlay network and would just send point to point among the various peers. There are similar systems that still do the same thing today. Tailscale is a good example of one. It's based on WireGuard, and it does the same kind of point-to-point, where the actual point-to-point setup is handled by Tailscale, coordinating everything in the background and using WireGuard to create these tunnels. Another one that I have seen, have not used directly, is Zero Tier. Same idea. You can put it on any node you want. Another commercial provider that does something similar that I have seen in my work environment is Citricom Control 1. Same idea. Any station that has the Control 1 agent joins this overlay network. And in that context, when they try to go to the internet, it's going through Control 1, and therefore their corporate router can be anywhere in the cloud, typically speaking, and it'll go through the cloud, go through the corporate firewall and all the policies there before exiting onto the main internet. And this is part of where the overlay network can make sense in very specific situations and not as much sense in others. Because if you think about it, let's say you have a physical office. Things like Tailscale or Citricom Control 1 or any overlay network really would say, okay, what you want to do is you want to put this overlay agent on every single machine. Here is a machine. It is a server. You can tag it as a server. This machine over here is a user workstation. Tailscale keeps track of this by an owner for each machine. Either it is a user or it is a tag for a machine that doesn't have a specific user, like a server. But if you have an office, does that make a lot of sense? If you have an office and you're like, well, why do I need to put the overlay on every single one of these machines in order to have them communicate with each other? They're on the same actual network. Does that make sense? No, not really, is the answer. No, it really doesn't make a lot of sense. So what do we do instead? Well, what we end up wanting to do is kind of a mix between these two concepts. What you really want is, if you have a local network, you want a device, kind of like a traditional VPN, that will handle all of the traffic for that local network and then become their gateway into the overlay network. And then when other devices from outside the office want to connect to one of those machines, they just need to connect to that overlay gateway, and then that'll proxy their traffic in there, just like a standard router doing network address translation. Where overlay networks really come into their own is if you don't have a local office at all. Let's say you've got 1, 2, 3 servers. Okay, where are they? If you don't have an office, maybe one of them's a virtual machine in the cloud. Maybe it's an actual server in a co-location facility somewhere. Maybe you need a dedicated machine because you need the hardware resources, and you have the machine there, but you don't really have anything else. Okay. And then all of your clients, one person's in Calgary, one person's in Vancouver, one person's in Kamloops, one person's in Revelstoke, one person's over in Ottawa. Okay. This is a perfect example for where an overlay network would work well. You can put an overlay agent on each one of those users' stations, and then you have an overlay agent on the servers, whether it's one in the cloud or whether it's in a co-location facility. And now all of these machines can talk to each other on their local network overlay, and they can function even though they're all in different places. There's no office, there's no specific office network that they're a part of. And this allows you to treat all of these machines as if they were a coherent whole. It's VPN, but very specifically, I differentiate between a VPN where you have one central location or a few central locations that people need to connect into that may or may not be connected with a site-to-site tunnel if there's more than one central location, versus an overlay network which is designed to be peer-to-peer. And you can do some of these in a hybrid sort of fashion. I use Tailscale quite a bit as a VPN replacement for customers because it can do other things. For example, it links into an external identity provider. Great. I can, use the external identity provider rather than having to provision a bunch of separate VPN accounts. That external identity provider might have multi-factor authentication, and for my clients, it definitely does. So that means that their VPN connection is now being authenticated with a multi-factor authentication flow. And that's a good thing. So, which they don't have to set up separately. They can use the same thing that they already have. Great. Wonderful. And that, allows that sort of a hybrid solution to work. They can install the overlay agent on remote workstations. I can have a local, gateway, essentially, that is the gateway into the overlay network. It does the same thing as a VPN. Even though I've got a central location and I'm putting an overlay agent on the other stations, it's exactly the same functionality as a VPN. But then you can take that same system and you can go further with it. For a customer that doesn't have a local network at all because there's no office, you can do something like what Citricom Control 1 does and what it's designed to do. It's designed to have the firewall as such with all the corporate policies in the cloud. And then all of your workstations have the Control 1 agent. You can have one out there, maybe two in a WeWork facility or something like that. And they'll all be going through the corporate policies, which is a firewall, virtual machine, a virtual firewall in the cloud. And that's how you centralize it. You can do the same thing possibly with like a little hardware device. You plug a computer into it, you plug a phone into it, great. Now this little device becomes the overlay gateway for both of those two devices, phone and computer. The computer might go through a separate policy. The phone might go through a QoS adjusted connection to a specific phone provider. But you have a single hardware device that can handle both of these and becomes the overlay agent, sort of like a mini gateway that does VPN for the two different devices. There's a lot of interesting flexibility that you can add if you break away from the harder concept of a VPN has to have a server location. It has to have a central location where all the remote clients connect into. If you go, well, maybe that works for some people. Maybe that works for some networks and some systems. But if you go even further to there is no central location whatsoever, everybody just needs to connect to the devices that we're using for this particular business, that's where overlay agents and overlay networks can really come into their own. And it's an interesting thing because if I go back to the earliest example that I'm aware of, or that I at least mentioned in this video of LogMe and Hamachi, remember what it did. It was essentially looking to provide LAN connectivity for games which were not designed to work over the internet. And with a good overlay network, you can do the same sort of thing. Let's say that you have an application that is supposed to be able to, connect in the local network. But for whatever reason, it's not really intended to function over the internet, or it's something that you shouldn't put on the internet because it's not secure. Traditionally, you might say, okay, well, I need a VPN so that people can connect to this. And yes, you can do that. It works. That's one of the benefits of using a VPN. But if you don't have that central location or a router specifically to do that VPN connection, maybe an overlay works better. Because maybe you don't even have a server in this company. Maybe, like with Hamachi, you just have a bunch of desktops. Maybe this person has a dev environment that they're running a proof of concept on their machine, and you want everybody else to be able to connect to it. An overlay network is a good way to do that. Maybe somebody else has a different dev environment and they want everybody to go and look at how they've modified it. Again, you don't need a central server necessarily if that's not what works for the business. The overlay network can handle it. So being able to think through how you start with one concept, a very basic concept like NAT, because everybody sees NAT and everybody kind of understands how it works on one level. But then there's multiple levels to NAT. And then it turns into a VPN where you're doing the same sort of translation, except you're not translating anymore. What you're actually doing is encapsulating the entire packet and shoving it through unchanged. And then you go, okay, well, but maybe I can do this in a fully peer-to-peer environment where I don't have to worry about the gateways unless everything is on the local network anyway, and then I kind of want a hybridized system. There's a lot of flexibility that you can do with networking, so long as you understand the concepts and then think through carefully how to apply them in a way that works best for your particular purpose and your particular environment. So there you go. Something fun to think about. Hopefully you did find that fun. Hopefully you found that enlightening, had something to chew on there. If you have thoughts on other things that you would like to hear me talk about or things that you would like to see me demonstrate, feel free to let me know right down there in the comments section. Otherwise, thank you very much for watching. I am your next door netadmin, and we will see you next time.